afternoon, students. Now, coming back to our paper Software Engineering, we had an introduction about software engineering and evolution of software engineering already, and also how it differs from an art form and the need for software engineering. All that we had seen already. Now, based on that, we shall move on to our next module, software development projects. As you know, software projects are developed for commercial purpose. For example, Microsoft Windows, Oracle, DBMS, etc. They are all commercial softwares. That means they are developed for commercial purpose. Maybe a generic purpose, like the Microsoft Windows, etc., DBMS, etc., are developed for generic purpose. Another even more complex software such as railway reservation system, nuclear power plant, etc. are there. More sophisticated systems are also developed. So they are developed for a specific purpose. So mostly software development projects. Software projects are developed for commercial purpose. Either it could be a generic or specific particular purpose softwares. In either case, there may be sophistication or complex softwares are developed. As a computer science student, you may know what is the difference between a program and a product. The programs are short, small codings that you may do in your assignment or for your practical purpose for knowing something about that programming language. So programs are developed by individuals, by an individual programmer for their personal purpose. So programs are always small codings that is developed by an individual, like that the programming you do in your practicals. For learning about a programming language, so it is developed by individuals, and the developers of that program, or those who write those programs, are called as programmers, and these may be developed for their personal use. And of course, programs are always small in size with a limited lines of code, and it has a limited functionality. And considering a program, the author of the program or the programmer, he himself would be the user of that program. That means the program is developed for his own use, and he himself maintains the program. The program is developed by himself and is used by himself and is maintained by himself, so that it lacks good user interface. If the software is developed for someone else, or for some other concern, for some other business concern, the program should have a good user interface, because it is used by another person other than the developer. When it is used by another person other than the developer, the program should have a good user interface. But uh, for a program, for a small program, the program may be developed for his own use, and he alone will maintain the program, so he know what he has done in that programming. So there should not be a good user interface, and a good program lacks proper documentation. For a software there must be good documentation, we should specify the requirement specification document, design document, text document, user manuals, etc. But for a specific program, when we consider a particular program, it will be always small in size with a limited functionality, and that is used by the programmer itself, and he knows well what he had done in that program. So he does not need to provide a good user interface, and he should not provide a good proper documentation for that, because he alone is using that software. Sorry, not software, program. So as computer science students, you are well aware of programming. So you can specify the difference between a program and a product. Product would be always a software. As we said earlier, products are considered as a fully developed software. Fully developed software will be used by a specific business organization, or likewise for any other purpose. That might be a generic purpose, or it may be developed for a complex sophisticated specific purpose software. In either case, software products, product, when we consider a term product, the product refers to a completely developed software, and this software will be used for commercial purpose. So considering product would have multiple users. For programs, the programs are used by a single user, whoever may be the programmer. He alone would be using that program. But for product, the products are always used by other persons, maybe one, or it may have multiple users. If we consider the Microsoft Windows, or likewise, it would be using by many more types of peoples. So it has a multiple users, or usually generic purpose softwares are used by multiple users, and it must have a good user interface. It is used by other persons, means it is used by others other than the software developers. So for the customers, if he could use the software in ease, there should be a good user interface so that he could learn to use that software with that easiness. So there must be good user interface, and of course there should be proper documentation. So we know, for all softwares that are developed for other persons or for other organizations, the software should be well documented. First of all, it should contain a requirement specification document. From that, the process of software development starts from the requirement specification document to specify the requirements of the customer, and then a design document from which the other team members could know what is the planning of that development process. So there should be a design document, and after completing all the development process, there should be a test document to specify the test suite or test cases used to test that particular software. And there should be a user manual. A good software always should contain a good user manuals also for any products. If it has a physical appearance, or like software that doesn't have a physical appearance, user manual is necessary for all the things, because without a user manual, the users could not get the knowledge, or could not learn how to use that product. For software or for any other product with even physical appearance, could not be used with ease by a customer without reading an user manual. So user manual uh, is also a necessary thing, important thing considering the software development projects. So it should be the products are used by multiple users, so they may be generic or even they may be developed for a single business organization. In any way, it should contain a good user interface, and it should contain a proper documentation, and the software products are systematically designed, uh, but for programs are not that systematically designed. Softwares are systematically designed, they are well planned. The development process is always well planned one. They are systematically designed and carefully implemented. They are not roughly, they are not making use of a rough knowledge or a vague knowledge of programming ideas. They are systematically designed and carefully implemented, and they are thoroughly tested. They are used by, softwares are always used by other persons, the persons other than the developers. So the software should be thoroughly tested by suitable test suits and test cases. So each and every part, each and every part of the control structures would be tested. So it is always thoroughly tested using many testing ideas. And a product is always developed by a group working as a team. The developers of the softwares are always termed as software engineers because they apply a specific uh, design process, they apply specific planning, and they are systematically designed and carefully implemented. For that reason, as we said in the earlier class, for certain reasons softwares are engineered, not crafted. And here products are developed by a group working as a team. So it is a teamwork, and it is not developed by a single person. If a, uh, if it is developed by a single person, it would lack in its perfection, and it would lack in its specifications. So in that case, we consider it as a program. If it is developed by a single user or a single programmer, it is termed as a program. But for a product, as I said earlier, product is a completely developed software, and for a completely developed software, the software would be developed by a group working as a term. And always the developers of the software are termed as software engineers. And now, emergence of software engineering. We learned already the evolution of software engineering, the evolution and its difference from a craft or a science form. So it is always engineered. So software engineering techniques have evolved over many years in the past. As we said earlier, it have been evolving through 60 to 70 years. This evolution is a result of a series of innovations and accumulation of experience about writing good quality programs. Always the development happens, for any technical terms, the development always happens because of a series of innovations. Without innovation, a technology cannot be developed. So it is a result of a series of innovations and accumulation of experience too. As we said, it is the past experience. From that, we learn the mistakes from the past. So it is the result of the emergence of software engineering is of course the series of results from the series of innovations and accumulation of the experience we could recollect, or we could get learn from the past mistakes also. And about writing good quality programs resulted in the evolution of the software engineer. And there are a series of innovations. We shall examine a few of these innovations and programming experiences which have contributed to the development of the software engineering discipline. So learning about the early computer programming. Early means the first stage of computer programming. We can imagine early computer programming are too slow and elementary. We have such computers in the early stage, and as far as the programming is concerned, more powerful the computer, more sophisticated works could be done by using that computer. But for early computer programming, the computer itself is not that much developed, so the programming is also too slow. And elementary programs, the programs that could not be split it up into modules, it is slow. And there are small programs written in assembly languages. Before the innovations, before the development of all that programming languages that is available today, in those days, in early computer programming, they use only assembly languages, and assembly language programs are all too small programs, and it is executed too slow, and they are very small in size and lacked its sophistication. Usually the programs are written in assembly languages without they are programmed without any strategy or a particular plan or design. There must not be any plan or a particular strategy or design on developing such programs, and the programmers have their own style of developing using the earlier build and fix style. We learned what is a build and fix style. The programs are quickly developed without any planning or design. They are developed quickly and they are tested. And at the time of testing, they may um, discover some errors on the programs, as they are developed in their own individualistic style of writing programs. They are usually different to understand by the other persons also. So everyone had their own, no standardization on the programming on those days. They wrote the programs without formulating any proper solution strategy, plan, or design, and jump to the terminal and start coding immediately on hearing out the problem. There is no specification of the problem, there is no analyzation of the program, and there is no documentation. They are simply building or developing a software quickly, and after fully developing the software, they are testing it. So this process is called the build and fix style that is used in early computer programming. And these programs make more computational time. They make use of the CPU utilization. They used the CPU utilization for those programs are very high. So they have more computational time. And next programming is high level language programming. With the innovation of semiconductor transistors, semiconductor transistors are more faster than that of the earlier computer programming. So with the use of faster semiconductor transistors, uh, This is about early 60s. In early 60s, computers become more faster with the introduction of the semiconductor technology. And these semiconductor transistors replaced the vacuum tube based circuits. In early computer programming, they used vacuum tube based circuits in the computers, and they are replaced by the semiconductor transistors, which are more faster. So they had a more powerful computer, they had a more powerful hardware, and with that more powerful hardware, they are able to solve larger and more complex problems. And by this time, uh, high level languages such as Fortran, Algol, COBOL were also introduced. So there was an increase in the power of hardware, as well as more high level languages are also discovered. Instead of that assembly language with more complications in using the pseudo codes, more uh, flexible language such as Fortran, Algol, COBOL, such high level languages are introduced in that period. And these high level languages reduced the effort required to develop software products and helped programmers to write larger programs. So, using the assembly language coding, pseudo coding, the programmers, the effort was higher. The programming effort was higher, and they could only write small programs without any complex logic, using any complex logic. But with the high-level languages such as Fortran, Algol, or COBOL, the effort of writing program is reduced, and the programmers could write larger programs. Uh, so this enables the programmer to write several machine instructions, uh, but still they use limited lines of code in their programs. Because they are still using the exploratory style of software development. That is, they had their own individualistic style of developing the software. There is still no standardization. So, as we said, the first programming was the early computer programming, which uses more computational time. They are slow and elementary, and they small in size and lack sophistication, and they are developed in a built and fixed manner. For high-level language programming, the vacuum tube were replaced by the use of faster semiconductor transistors. So the things became somewhat faster with the development of more programming languages. High-level languages were developed, and it reduced the effort of writing the programs, but still they have limited lines of code, and they still used an exploratory style of development. So there is no standardization in the programming. Coming to the next one, control flow based design. Control flow structure indicates the sequence in which the program's instructions are executed. Because the programmers found it increasingly difficult not only to write the cost effective and correct programs, also it is to understand and maintain programs written by others. It is difficult when all the programmers use his own style of writing programs. It is difficult to understand the program and maintain the programs written by others. So, to solve this problem, experienced programmers advised other programmers to pay particular attention to the design of programs' control flow structure. So, if the program has a good control flow structure, the program would be easier to understand and maintain, easier to understand by others also. So control flow structure indicates the sequence in which the program's instructions are executed. That is the sequence, the series with which the program's lines or statements are executed. So this flow of execution of the statements are stated as the control flow structure. Each and every program has its own flow of control. So the control flow structure indicates the sequence or the series in which each and every statements of the program are executed. This control flow structures make use of flowcharting. So the advantages of control flow based design are it is cost effective and correct programs. Because when we write a program, we are uh, considering the flow control flow structure, that is the sequence with which the statements are in the programs are executed. So always the programs could be written in a better way, so more correct programs, and it is always easy to understand by others also, and it is easy to maintain by others because it uses a flowcharting technique. It has a documentation with representing the control flow using a flowcharting techniques, which is easier to understand, and it helps to maintain good control flow structure because we can analyze the flow of control or flow of execution through the program or using a flowchart. So it helps to maintain a good control flow structure in the program, and it has a clear execution sequence. Because we can analyze, as we can analyze the path of execution, the sequence of execution, we can provide a good programming style using the control flow based design. As an example, we could see coding, a part of a program showing the difference between an unstructured and a structured program. A program with a good control structure is termed as a structured program with a good control flow, with a good flow of execution, is termed as a structured program. And what is the difference between an unstructured and a structured program? Seeing, if you see the figure A is an example of an unstructured program. See, if the customer savings balance greater withdrawal request, then issue money. So they are using a if statement, and within the if statement they are checking for a condition. If the savings balance, account balance, is greater than the withdrawal request, if the amount requested for the withdrawal is less than the current balance, so if the balance is greater than the withdrawal request, issue money equal to true, then issue the money. And issue money statement itself is using a label 100, then it uses a go to statement, go to 110. So from that, the flow of execution, the control of execution transfers from the third statement to the seventh statement. So the first statement labeled 1, 2, 3, 4, the first statement, after execution of that first statement, if the current savings balance is greater, then the control transfers to the second statement labeled as 100, and then to the third statement, and from the third statement the control transfers straight from the to the seventh statement. So there is a path, first statement 1 to second statement, then from the second statement it transfers to the uh, statement labeled 110. If the condition is true, if the condition specified in the if statement is true, the sequence of execution will happen. If the condition given in the if statement is false, if the current balance is less than the withdrawal request, what will happen? The else part of the if statement will be executed. If the condition provided in the if statement is wrong, is false, Then the control of execution will be transferred to the else part. The else part is given in the fourth statement. If privileged customer equal to true, then go to 100. That means issue money. So first of all, it is checking whether the customer's current balance is greater than the withdrawal request. If it is true, money is issued. If it is false, then check for if it is a privileged customer. For a privileged customer, again, it is true to issue money. Yes. So even after specifying the else part of the if statement, there is a go to statement, go to 100. So the flow of execution is jumped from one statement to other statement to different parts of the same program. And again, else part is given as else go to 120. 120, it is printed as error. So, and the next part is labeled as 110, activate cash, dispenser and withdrawal request. So, after activating the cash withdrawal, and again there is a go to 130 statement to end the transaction. So this is a completely unstructured program because it contains more go to statements, and the path, it has more path considering or comparing with the structured program. The same logic, the same program can be written with another logic, with another specific codings. See for the next figure B, if privileged customer of customer savings balance greater than withdrawal request. Here also we are checking for the same that's done on the first part. But it is more complicated. The A example is more complicated comparing with the B. In the B, the corresponding that the same program is the same logic is done in a specific manner, in a different manner. That is checking with an if statement. If privileged customer. So the cash withdrawal is possible for a privileged customer without checking for his balance amount. So check whether he is a privileged customer. So first we are checking for a privileged customer. If the privileged customer condition is true, then checking for the second condition, check customer savings balance is greater than the withdrawal request. If this is true, the second statement will be executed. That is, activate cash dispenser of withdrawal request. So it checks for the privileged customer and the customer current balance in the same statement with a single if statement, and then the control of execution transfers from the first statement straightly to the second statement. And then if the if part, if the condition checked using the if statement is false, the control will be transferred to the third statement. So there are two conditions. If it is true, if the if condition is true, the control of execution will be passed to the second statement. If the condition specified using the if condition is false, the control of execution will be transferred to the third statement, the else statement, else print error. And in either case, if the condition is true or if the condition is false, the control will be transferred to the fourth statement. So the path of execution is clear when using the structured programming, other than the unstructured program, which with a more complex control flow graph. We shall see the control flow graph for the earlier said two programs. So when using the first program, that is program coding A, it has a more sophisticated control flow graph. The execution starts from the first statement, then from the first statement the execution passes through the second statement or to the fourth statement. We have used an else statement there in the fourth statement. So from the fourth statement, it the execution flows through the fifth statement, and again it skips back to the second statement. From the second statement again it comes to the third, then seventh, because we have used a go to statement there. So the control of flow of execution jumps from every statement and skipping other parts of the statement. So it has a more complex control flow graph. But for the same problem, for solving the same problem, using the same logic, we had termed another set of statements in the B coding. In that, the lines of codes are also small, and they used a simple way to check the same condition. In that, the flow of control, the execution starts from the first statement, and the flow of control is transferred to the second statement, or if the condition is false, the flow of control will be transferred to the third statement. So starting from the first statement, it may either shift to the second statement or to the third statement. In either case, if the condition is true or false, in either case, the control will be transferred to the fourth statement. So it has we can see it is clear. It has a clear flow of control graph. So figure B, that is the second structured program. Structured programs always have a clear control flow graph. This is the control flow graph for figure A and B. So it has a structured program uses a clear graph. See, for the program in figure A, there is an unstructured program. We shall see the difference between the control flow graph of an unstructured program and the control flow graph of a structured program. So the control flow graph of a structured program is more clear comparing with the unstructured program. So when using such structured programs, normally one could understand a program by mentally tracing its execution sequence. That is, one could try to understand how the output is produced from the input values. So we can trace back from the statements to know how the input changes into an output. So we can start from a statement producing an output and trace back the statements in the program and understand how they produce the output by transforming the input data. So these type of structured programs, in using the structured programs, anyone can understand the program with such ease because it has a clear control flow graph. And in many cases, the control flow graph of a program will be too complicated with the use of too many go-to statements, as we said in the example A. It uses many go-to statements, and the go-to statements completely spoils the program control flow of the program. Using many go-to statements cause too many paths in the CFG. For example, in the figure it is shown, whenever we use a go-to statement in our program, it creates more control flow path in the program. Too many path in the CFG control flow graph causes reduced understandability, and it causes complications in debugging the program also. It is more the program becomes more complicated with the use of too many go-to statements, and it because it creates many path, as it creates many flow of control, many path in the execution of the program. It is difficult to understand the program, and it is difficult for debugging, testing the program also. So to reduce this difficulty of using go-to statements, we use the another programming constructs, sequence, selection, and iteration loops in our programs. So it provides the program a modular look. So the program will be more modular. And with the innovation of other programming languages, Pascal, Modular, C, etc., these programming language provide the use of these constructs: sequence, selection, and iteration types of constructs, so that the program becomes more modular. So students, I hope you understand. The materials for the same class would be uploaded on the Google Classroom. Try to learn. Wish you happy learning. We shall see you on the next class.